Before we start creating and deploying vApps, it's important to understand exactly what a vApp is and what the requirements are to use it. If we look at a simple vSphere architecture diagram here, let's say that we have three hosts managed by vCenter in a cluster. We can deploy a vApp that we either create or download from the internet or a solution provider. And let's say that this vApp contains three virtual machines. It could contain just one or it could contain many more. But in this case, it has three virtual machines. And this is our multi-tiered application with a web front end, a SQL database server, and some sort of analytics server. All of these virtual machines are self-contained in the vApp. They have their operating system already installed, applications already installed, and configurations already in place. The benefit of the vApp, of course, is that we can power all of these virtual machines on and off together, and we can even do it with a startup and power off sequence. Because, for example, in this scenario, you would probably want the SQL server to be powered on first, and then the analytics server, and then once that's up and running, the web server would be powered on. All of this can be automated, and each virtual machine won't be powered up until the previous virtual machine is successfully powered on and up and running. And then let's say that you needed a development environment. Well, you could easily clone this vApp with all of these virtual machines self-contained into a new vApp that you use for testing, training, and development. And finally, this is a point of administration. So in vSphere, you could authorize developers to just be able to administer, power on and power off the development vApp environment that you cloned from production. So now let's compare the difference between a virtual appliance and a vApp. A virtual appliance is a portable virtual machine that's self-contained. You could think of it almost as a zip file, a compressed single file that contains all of the relevant virtual machine disk and configuration info. And that's exactly what an OVA formatted file is. It's the Open Virtualization Appliance format. That virtual appliance already has the operating system installed and likely already has applications installed as well. You could create a vApp, you could share it with a friend, you could post it on a virtual appliance marketplace of some kind, of course, always keeping software licensing in mind. A vApp takes this to a higher level. A vApp might contain virtual appliances, or you might create a vApp manually in your vSphere infrastructure, which is something that we'll be doing in this module. The vApp provides that higher level management construct that we talked about for administration, for power on and off with a sequence. You can clone a vApp that contains many virtual machines. A vApp also provides resource controls, so I can restrict the resource consumption of the virtual machines in the vApp, and I can also provide a network pool of IP addresses. vApps, in comparison to virtual appliances, are a VMware construct. This is a VMware idea, and vApps aren't portable to other virtualization platforms such as VirtualBox, whereas an OVA virtual appliance most likely would be. When it comes to specific vApp requirements, vApps allow you to easily deploy and manage multiple related virtual machines. Back to our example with the multi-tiered application. vApps, like virtual appliances, can be shared or downloaded, and vApp metadata is stored in vCenter, and that's a critical differentiator when it comes to comparing vApps to virtual appliances. It's also required that you have a vSphere cluster with vCenter and DRS enabled in order to create vApps. And while we don't go into VMware's DRS or Distributed Resource Scheduler in this course, you should know that Distributed Resource Scheduler is an advanced VMware feature that ensures that your applications receive the resources that they need when virtual machines are running in a DRS-enabled cluster. And by the way, it's recommended to back up vApps to an OVF package to preserve that metadata, or use a backup application that supports vApps or will back up your vCenter database. When it comes to creating a vApp in VMware vSphere, it's easy to do. In fact, let's go to the vSphere client and I'll walk you through the process step by step. Here in the vSphere client, I'm going to go to our DRS enabled vSphere cluster. I'll right click and select New vApp. And it's here that we find the wizard that walks us through a 4-step process to create a new vApp. We do have the option to clone an existing vApp if we wanted to do that. But in our case, we've never created a vApp before, so we're going to select Create New vApp. And the most common use case here, again, is the multi-tiered application. So let's say that at the Wired Brain Coffee Company, they have an enterprise application that requires a web server, a database server, and an analytics server. These are 3 separate virtual machines, but they really need to control the power up order of these virtual machines and the power down order of these virtual machines. And then to be able to do it with a single click, whether it's a power on or off, clone those virtual machines together and assign management responsibilities for the administration of those virtual machines together as a unit, or in this case, as a vApp. So we'll choose to create a new vApp. Let's give this vApp a name. We'll call it Multi-Tier App 1. We'll select a folder or data center. In this case, it's just going to be Hilton Head, South Carolina. That's our virtual data center. We'll click Next. And then we're prompted to configure resource allocation for the vApp. Now, when you create a vApp, a resource pool is created inside the vApp by default. And while you're not required to configure resource reservations for CPU and memory, it is a great benefit of using vApps. Now, we've got a whole nother course coming up on resource allocation and performance in vSphere, so we're not going to go into how to configure shares, reservations, reservation types, and limits across CPU and memory, because that is something we'll be going into in a later course. But just know that you can configure resource allocation on the virtual machines running inside the vApp. From there, I'll click Next and Finish. And then check out the new multi-tier app 1 right here on the left-hand side. This is the new vApp that we just created. In the next lesson, I'll show you how to add objects, which are virtual machines, to the new vApp that we just created at the Wired Brain Coffee Company. When we talk about adding objects to an existing vApp, what we're really talking about is adding virtual machines. So we said that vApps are ideal for multi-tiered applications. So these objects that we're going to add, well, it makes sense to add multiple virtual machines to create those multiple tiers. The easiest way to do this in the vSphere client is simply to drag and drop. If you have existing virtual machines you want to add, for example, our web server running Windows 2019 that we've created, we could take it, click on it, drag it over, and drop it into the new multi-tiered app 1 vApp that we created. And look at that. We just added a virtual machine to the vApp. If we click on the vApp, you can see here underneath virtual machines, there is Web Win 1 that we created, now part of our vApp. To really demonstrate the power of vApps, it makes sense to create a few more objects, in this case, virtual machines, inside the vApp. But I want to point out here, because it's on the screen, not only can you add virtual machines, which would be the most common thing that you would be adding as an object, but you can also add a vApp to a vApp. So you can have nested vApps in a vApp. So perhaps you have a multi-tiered application, and each one of those tiers, web, database, and analytics, is made up of multiple virtual machines. You might want to put each tier of the vApp in its own vApp. So you would have 3 web servers in a vApp, 3 database servers in a vApp, and 3 analytics servers in a vApp. That is possible with vSphere, and all 3 of these child vApps would be inside the parent vApp. Now, in our case, we're not going to do that. What we're going to do is to create 2 new virtual machines. I'm going to take the defaults for these, and these, I'll just tell you, are going to be empty virtual machines. We're not going to install operating systems in them at this time. We're going to use them for demonstration purposes. So we'll call this SQL Web 1. And notice now we can deploy this virtual machine inside or into the vApp. We'll put it on the vSAN data store. So there's our SQL database server. And now let's add one more. We'll call this logging or analytics. We'll deploy it inside the vApp. And now we have our 3 virtual machines inside the vApp. Notice, as I mentioned, if you right click here, you can create a new child vApp inside the parent vApp. You can also create your own resource pool running inside the vApp. With our 3 virtual machines added to the vApp, let's now move on to the next lesson where you'll learn how to configure and control this new vApp construct. There's a lot that you can do with a vApp. We talked about power up, startup order, permissions, resources, and more. If we go here to the vSphere client, you can see we've selected our new vApp. We've got 3 virtual machines contained inside the vApp. One of those is powered on. And if we right click on the vApp and go into edit settings, it's here that we can configure the resources, which could be very helpful to limit the resource consumption of the virtual machines in the vApp. We can configure the start order. For example, in our 3-tier application at the Wired Brain Coffee Company, let's say that we want the SQL database server to start up first. We'll change this to group 1. From there, we want the logging server to start up second. That would be group 2. And then finally, we'll have the web server start up last in group 3. Notice that there'll be a 120-second power-up delay in between each of the 3 groups. And we do have the option here to only continue with the next power-up in the sequence once VMware tools are up and running. That's how vSphere knows that the virtual machines have successfully powered on and that their operating systems are indeed up and running, because the VMware tools would start and the VMware tools would be communicating with VMware vCenter. So that's how you configure the startup order for the virtual machines in the vApp. We'll talk more about networking here in a moment. You can also configure details for the vApp, such as a product name, which might be the Wired Brain Coffee Company coffee application, the URL to download this vApp, the vendor, and the vendor URL. I'll click OK here. And now we've configured the startup order for this vApp. So with that, we configured the startup order by editing the settings on the vApp. Now you can also go into the vApp and you can monitor issues. You can monitor both overview and advanced performance utilization, tasks and events related to the vApp, as well as CPU, memory, and storage allocation. You can also monitor utilization of the vApp overall. If you go into the Configure tab, you can configure custom properties for the vApp. You can assign permissions for the vApp overall. This is where I talked about you could assign specific users. For example, the developers might need to administer the developer 3-tier vApp that you cloned from the production vApp. You can configure resource pools, and then of course view which virtual machines, data stores, and networks are a part of this vApp. So that's how you edit vApp settings and of course configure the vApp once it's created. Now let's move on and talk about vApp networking. When using vApps, the virtual machines inside the vApp are going to need an IP address. So one of the requirements is that you configure something called IP pools. IP pools provide the network identity for the virtual machines in the vApp. Now, IP pools have relatively recently been renamed Network Protocol Profiles. If we look here in the vSphere client and we go up to the virtual data center level where we've deployed our vApp and go into the Configure tab, you'll see Network Protocol Profiles. And this is really only used if you're using vApps or certain virtual appliances. To add a new network protocol profile, you click Add. We'll give this a name. We'll just call it Wired Brain Coffee Company IP Pool 1. And then here you'll need to select which virtual switch this IP pool or network protocol profile will be associated with. And it could be a distributed virtual switch, distributed port group, more specifically, or a standard virtual switch, which in this case they just call networks, and we would associate it with the VM network. We'll click Next, and then we need to provide some IP address information here. Let's start off with the subnet, and then we'll provide our gateway IP address. We'll want to indicate that a DHCP server is present on this network. We'll provide the DNS server IP address. You'll want to enable the IP pool. And then finally, provide the IP pool range, which is done by providing an IP address and then a number sign, followed by the number of IP addresses that will be following after that IP address in the range. If you click here to view the range, you can view the exact IP addresses that will be in this network protocol profile or in the IP pool range. I'll click Next here. We'll skip any IP version 6 information. And then, of course, you want to provide DNS information here as needed and click Next and Finish. And that's how you create a network protocol profile, also known as an IP pool. Now back to our vApp. If we right click on this and go into the settings and then into IP allocation, it's here that you can configure the IP allocation for the vApp, specifically which IP protocols will be used, and then how to allocate the IP addresses, if you'll use DHCP or if you'll use an OVF environment, which could map back to this static IP pool or transient IP pool. The only difference being whether or not the IP addresses are given back once the IP addresses are used. I'll click OK here, and we just configured IP address allocation for the virtual machines that are part of this vApp. Earlier, we configured the power on and power off order for the virtual machines in our vApp. Now let's see how we can use that when performing power operations, and also explore how we can suspend and resume a vApp. With our power on and power off order configured here in the Start Order tab, let's go ahead and power off our vApp by right-clicking on the vApp and going up to Power. We'll select Power Off and say Yes. Notice that we powered off all 3 virtual machines at the exact same time. Now, if we go to the vApp once again, right-click and say Power On, notice how we're starting the vApp, which includes first starting the SQL database server. And if you recall, we configured a 120-second delay between each of the virtual machines in the vApp. And because of that, I'll need to speed up the video so that you can see the results of this power on operation faster. And with that, you can see all 3 virtual machines successfully powered on and our task to start the vApp successfully completed. Besides powering off and powering back on an entire vApp, you can also suspend and resume a vApp. And this is very similar to power on and power off. If you right click on the vApp and go up to power and then over to suspend, we'll say yes. And then it will go through the same process that's very similar to the power off process, where each of the virtual machines will be suspended in the order of the startup and power off grouping that we configured. Once the virtual machines are suspended, you can go back in, right-click on the vApp, go to Power, and the Suspend button will be turned into a Resume button. You can easily resume the virtual machines. The benefit of a Suspend and Resume is that you're able to preserve the memory of the running virtual machines. In other words, when you resume, you don't have to reboot the operating systems. The operating systems, applications, and data in memory are all still available and immediately come back on once the virtual machines are resumed.